Hi everybody, in this video, I'm still looking at Athena cycles, but I'm on the product mix worksheet. So with most companies, they don't just produce typically one product, we'll say, or sell only one product. And Athena cycles is the same. They have 4 different bicycles that they produce and sell. So here we're looking at 4 different bicycles. We have Athena 1, which is the lower level, more entry level bicycle, we'll say, for 1400. Athena 2 for 1800, Athena 3 for 2200, and then the Athena Racer goes for 3000 or sells for $3,000, right? So you have a variety of costs here or sale prices, and then also quality, right? So assume that your Athena Racer is catering more to your elite cyclist who is probably doing races and training and things like that. So what Athena is doing is they want to figure out what their optimal mix is, in this case, in order to really maximize their profit. When I say optimal mix, they want to know how many of each style should they produce, right? Should they produce 1,000 of each? Should they produce 5,000 of each? Should they produce more racers or more Athena 1s? Like how much should they produce? So what we have in this worksheet is we have a lot of background information already given. So for each of the bicycles, you have their material and manufacturing costs. If you scroll down, we also have functions already given for the revenue. So this is already for the revenue, looking at the price times however many we produce. And then we do have a breakdown as well of total revenue, material cost, manufacturing cost, fixed expenses, and then finally net income. And this includes all of the 4 combined. Now you can see I have some labels here as even product mix, optimal product, or optimal product mix really. And even product mix assumes that we should produce the same number of each type of item. Now, in this case, Athena Cycles wants to produce 12,000 bicycles. So that's sort of their ideal number. That is how many they believe that they can produce and sell within a certain period. So their production schedule is looking at 12,000 bicycles. So an even product mix would evenly distribute that. If I have 4 different kinds of bikes, I would make 3,000 of each. So the numbers in green here that you see are that even mix. So we're making 3,000 of each style. And we have a column dedicated just to the even mix. And the profit there, or the net income, would be about $1.3 or $1.4 million. Now, maybe this is not the best option though, right? So we don't have to make exactly 3,000 of each style. I just need to make 12,000 bikes altogether. So what you could do is you could play around. So for instance, maybe we only make 1,500 of Athena 1, maybe we make 2,500 Athena 2 bikes, 3,500 Athena 3 bikes, and we make 4,500 Athena 4 bikes. So what you're seeing here is they're comparing the number of bikes being produced to the even distribution. So we're making fewer Athena 1 and 2 bikes and more Athena 3 and racer bikes. And it's the same thing with the revenue. So you have the revenue based on the optimal numbers I put in, and then that change compared to revenue of the even mix. So under the optimal mix, one thing you see here is at the bottom, you see that net income. So our net income with the numbers that I just put in to play around is actually less than the even mix. So we can see here that the difference is $235,000, which is a decrease in 17%. So that's not the best mix. The other thing you do have here is you do want to make sure we're producing 12,000 units. So the formula here in this particular cell is the sum of the number of units we're producing. And I could go in and I could play around some more. So, all right, maybe this one didn't work, right? I kind of lost money there. So maybe I should do something different. Maybe I'll make more of the cheaper bikes. Not that they're cheap, but, you know, less expensive ones, and fewer of the more expensive ones, right? So let's try that. What happens there? So when I do that and I come down here, I can see, okay, I made my 12,000 bikes and I did better, right? Oh, that's a better breakdown. I made an extra $133,000 theoretically, right? That I'm going to sell all of these. And it's almost 10% better compared to the even mix. Now I can go ahead and I could play around with these numbers all day long, but there are a lot of different options, right? I'm making 12,000 units. I can have any combination of those 4 bikes with 12,000 of them. And they don't have to be even numbers either, in the sense that, I'm picking easy numbers, 3,500, 2,500. Maybe I need to pick 3,581 Athena 1 bikes, and then 2,767 Athena 2 bikes, and so on. So there could be a better option here that I'm just not seeing, and that I will probably not figure out if I keep playing around. So the first thing we'll do here is we're just kind of playing around, but we need a more systematic way in order to actually find the best solution. So what we're going to do is we're going to use an Excel add-in called Solver. Now, if you have the add-in, it's going to be under the Data tab, and I can see it over here on the right. I already have it installed on my computer, which is why you see it. You probably don't have it installed yet at home unless you've used it before. If you haven't used it, you're going to go to File. You're going to go down to either More or Options. So I'm using Excel 365 today, so I need to click the More button first, and then I'll see the Options feature. If you're using a different version of Excel, you may just see Options. And that's what you want. All right, let's see. I need to make sure, let's do a new share here. Let me just share my whole screen for a second so you can see it. And then when you click that options, you do see this box opens, and I'm going to hit add-ins. And if I scroll down, I'll see manage add-ins. And I'm going to hit go. And then you want to check off the Solver add-in. So if it's not checked off yet, you do want to check off Solver add-in, and then you would go ahead and hit OK. And now you would see it go into your data tab, and you'll see Solver on the right here. All right, let's make sure I'm working in the correct workbook here for you guys. All right, this looks good. All right, so I'm just going to share my workbook screen so that you don't have to see everything else going on in the background. But that's how we would install Solver. I did try it on the virtual lab as well, and I was able to install Solver on the virtual lab. So you can give it a try at home. If you do have a campus computer, a borrowed laptop, you may have issues installing the add-in because IT does restrict downloads. So if that's your case, you may want to reach out to IT for help, or you can also reach out to me and just let me know. But like I said, I also was able to do it on the virtual lab. So if you're having trouble on your own computer, see if it works on the virtual lab. All right, once we have it installed, I need to show you how to use Solver. So if I scroll down, you can maximize or minimize things in different ways, right? Depending on what your focus is. So for this particular problem, our focus is going to be to try to maximize this percentage. So we would like to maximize that change from the even mix. And there's different things you could do. So another person may say, well, I really want to minimize my costs, right? So you can do that. There's different ways that we can optimize things. The Solver feature is not only used for money examples, you can also think about shipping time. Maybe you have an Excel spreadsheet and you want to minimize the shipping time it takes to get your products to your consumers, right? So it doesn't have to just be money. It can be about minimizing time or minimizing wait time or maximizing profit, etc. So for this particular problem, our goal is to maximize our profits, particularly though, not just our net income. We would really like to maximize that percentage change. So that's what I want to focus on. So I'm going to hit the Solver button. And let's see if you guys are seeing this. Okay, good. All right, so when I hit the Solver button, up top, it's going to ask you to set your objective. And I'm just going to go ahead and delete everything for a second. I was working in Solver earlier today, and it has saved my information here. So let me just go in and start fresh. Okay. So the first thing I'm going to do is I set my objective, and this is the cell that you want to either maximize or minimize. So like I said, we're going to focus on maximizing that percentage cell. So I have cell E24 selected here, and that's what you're seeing here. I want to maximize this, right? Because I want to make the most money I can. So I'm going to select max. You also can find an exact value as well here, although I will say personally, I don't use that one as much. I tend to use max or min, but you could go ahead and use that feature. And then we're going to fill in the rest. So your changing cells are basically your variables. So these are the cells that we're trying to find the answers to. So in this case, I'm trying to figure out how much of each product I should produce, right? So the answers to that are in cells B11, C11, D11, and E11, right? Those were the cells that I was playing around with to try to find the optimal answer. So I select those and I'm telling Solver that, hey, this is where you're going to put the answer. This is what I'm trying to find. Now, you also need to provide constraints to Solver. So we do have some constraints here, even though they may not be obvious. Our first constraint is that we only want to produce 12,000 bikes. So we do have that restriction here that we're going to produce only, 12,000 of these bicycles. So I'm going to start by entering that constraint. So I'm going to hit add. And when I hit add, again, everything is typically in cell references. So if I look at my file here, that 12,000 comes into play right here in cell C19, right? That was the sum of those variable cells. So I want this to be exactly equal to 12,000. Now, we don't have too many options here. So you'll see you have less than or equal to, equality, greater than or equal to. INT means that I want integer restrictions. BIN refers to binary numbers, zeros and ones. And DIF is another type of integer restriction where it limits our values. So maybe our values can only be between 1 and 5, for instance. So we have pretty basic constraints here that we can use. So the first one that I'm going to add is that I want to make 12,000 bikes altogether. So I select the cell where that formula would be, and I set it equal to 12,000. And if I hit OK, I will see the constraint come in here. All right, now there are other constraints we actually have as well. So another constraint is I would only like to have integer answers. So I can produce, obviously, a fraction of a bike, right? I could stop the production, but I can't sell half a bike. So I'd really like to have integer answers here. So I'm going to add another constraint. And I'm going to select, again, my variable cells here, so where my answers would go. And I'm going to tell Solver that I would like these to be integers. So I'm selecting cells B11 through E11, and I'm telling cell, please make these integer answers. You can also do them individually, but you can add them all at once. All right, so let's go ahead and hit solve now. And Solver will either tell you that they have found an answer or they have not. So if they cannot find an answer, it is likely that you probably have an error somewhere. So I would go back and check your work. Or it may be that there is no answer, right? There may not be a perfect solution here. But more likely than not, you probably have an error somewhere. So I'm going to hit keep solver solution. I'm going to hit OK. And then what Solver will do is they're filling in the answers of the optimal solution. So if I look up here, my optimal solution is to make only Athena 2 bikes. So I make just 12,000 Athena 2 bikes. And if I look at my profit, I'm making an extra $1 million, and that's a 75% increase. So that's huge. That's amazing, right? You're like, oh, I got it. That's all we're going to do. Well, here's the problem. One problem is that most companies do want to diversify a little bit, right? You don't want to just make only one product. You want to have your clients coming back and purchasing new things. And again, not rely solely on one item. So even though this is the optimal answer, it's not really what I want to do. I do want to make sure I diversify. So I'm going to add in another constraint. I'm going to go to solver, and I'm going to add in the constraint that I have to make at least 2,000 of each type. So maybe the company decided, you know, we do want to make sure we have some of each style. Let's have a minimum of 2,000. So I'm going to select my cells again for my answers. And I'm going to let solver know that I need to have at least, so greater than or equal to 2,000 of each style. And I'm going to run it again. All right, so it said it has found a solution. I'm going to click OK. And I can see my new solution now is a little bit different. So we're still maxing out the Athena 2s because that must be where most of my revenue is coming in. But I am making 2,000 of the others as well. And if I scroll down here, I see, okay, not too bad. I'm still making 25% more than the even mix, making extra 342,000. So you're saying, okay, Professor Pollard, we're good, right? We have it. Well, we're not good. And I'll tell you why. So on the right here on this table, we have our parts, right? All these bikes require parts to build them. So I have a breakdown of which parts are used for each bike. But if you scroll further down, you'll see which parts we have available, right? So I do have only, 6,413 carbon frames. I only have 6,312 ultralight carbon frames. And if I look here, I'm using more frames than I have. So I'm using parts that I actually don't have in stock, and this is a problem. So I'm going to add in another constraint or another set of constraints. I'm going to have a constraint that says that my remaining value has to be at least 0. I can't have negative remaining values because I don't have those parts. So I'm going to go back up to my solver. I'm going to add in another constraint here. I'm going to use my cell references here. So I'm going to select my remaining cells. And again, you can do these individually. I'm just going to do them all at once. And I'm going to tell solver, hey, these really need to be greater than or equal to 0. I can't use parts that I don't have. That doesn't make sense. So I'm going to hit OK. I see that other constraint was added in. I'm going to hit solve again. All right, so I do have a solver solution. So let's hit OK. Let's see what we have this time. And I see that my new solution is going to be to produce 2,809 Athena 1 bikes, 3,381 Athena 2 bikes, 2,422 Athena 3, I think we called that Athena 3, and then 3,338 racers. And by doing that, I can go down here and see that my net profit is going to be about 1.4 million. So I'm going to make an extra about 47,000, which is 3.51%. So not as good as my last one, but my last option had me using parts that I didn't have, right? So when we have constraints, we really have to think about them in more detail and make sure we really think about what's going on. Now, there's probably more constraints out there too. So we're just kind of doing a simpler problem here, trying to maximize that percentage. And we do the best that we can. So there's some other things I want to talk about with you guys really quick before we go on. So with the solver, we use different methods of solving. So this method here, it still worked in this case. It's typically used for more complicated expressions that tend to be nonlinear. So you could have exponential or trigonometric constraints. If everything is linear, you could select simplex LP, which is another sort of strategy for how it runs. And then the last one is evolutionary, which tends to be for more complicated expressions that have more disjointed pieces. So there's a lot of jumps and holes in what the graph would look like. So there's different methods for solving. And sometimes I do produce different results. So the thing with solver is that it uses iterations to solve. So it will start with the value that is in the cell initially, and it'll kind of work around those values first to find a solution. And once it thinks it finds the best one, it will stop running. So what we have in mathematics is we have what are called local maxes and global maxes. So a local max is a maximum in a small area, whereas a global max is the overall maximum. So And the same thing is true for minimums as well. So sometimes solver will find a local max and think it is the biggest one and will stop. So that is a problematic piece here. With the simplex LP, this doesn't happen. It will find the global, but with some of the other ones, it may find a max, but not the biggest max, or a min, but not the smallest min. So it does help sometimes to just rerun solver a few times and make sure you're getting the same answer. And what you could do is you can try initial starting values in your variable slots, and that will help too. It'll kind of have solver kind of start in different places. And again, just ensure that you're getting the right answer. The other things that we can do when we solve is we do have different reports that can be run. So we can always run an answer report. Sometimes we can run what's called a sensitivity report, but sensitivity reports will not run if you have integer restrictions. So you can read in your book more about those here. Your book touches on it just very, very slightly, but they are sometimes used in to analyze the mathematics in more detail. And then the answer report as well, again, kind of gives you more detail about your answer. If you do an answer report, you could select outline, so that it outlines, and when you click OK, it will create an answer report for you down the bottom here. You can see I was playing around, I did this already, but here is your answer report. And it just kind of looks like this first. And you can also, if you do it in an outline format like I have here, you can, expand and close those different features if it's too overwhelming, for instance. In your answer report, it will tell you the final value is your answer. Your original value is what was in the cell beforehand. I was running this a few times, so my original, we've run this a few times. My original value is now the same. But your final value is your answer. So we're getting increased profit of 3.51%, and it tells you how many to produce. As you go down, you see some other things. So for your constraints, you have binding versus non-binding. Binding constraints are the ones that are restrictive because you don't have extra. So those are the ones where, for instance, see how this one is that the number of bikes is 12,000. So this is binding, meaning that we are making exactly 12,000, not 11,999, and I can make one more. It's exactly 12,000. There's no wiggle room. If I look at some other ones here, let's see if I can find another binding constraint. So here's another binding constraint. And this was one of our constraints about products, materials we have. So we made sure that we have at least 0 materials left, right? We don't want to have negative materials left over, so we're using more that we don't have. And some of these are actually at 0. So binding constraints are ones that are really limiting you. You're using all of what you have, or you're maxing it out, like you can't do any more. So if I had more Ultra Force shifters, then I would probably use them and change my product mix. Or if I had more Ultra Force 2 shifters, right? Because I'm using all of them, my cell values there. See how they're equal on both sides? If it's equal on both sides, you're maxed out. You can't do anything else. That's constraining you. So your constraints that are binding are ones where if you had more of that, or you could, push that limit, you would probably change your product mix. The ones that are non-binding mean that you have extra. So if you tweak them just a little bit, it's really not going to affect your final answer. You still have plenty of slack there. So I have 223 carbon frames left over. I have 502 ultralight frames left over, right? So I have plenty left over. So some slight changes there are not going to make a difference. So that binding and non-binding is actually an interesting piece and tells you really where you're being limited. Those binding constraints are the ones that are limiting your production in this case. Some other things that you can do as well is, as you rerun solver, let me go back to my other page here. As you rerun solver, you may want to run different scenarios with it. So you can save what you've already done. So I can hit the load or save button, and then you can select where to save it. It is telling you need at least 8 cells. So I can just select a range of 8 cells. Let's see, is that 8? And hit save. And then this will save my my solver piece here. So I can see that the final answer was 3.51%. And then what I could do is I could go into solver and I could change it. So maybe I don't want to maximize my percent. Maybe I want to maximize, maybe I want to minimize my cost. So let's change this instead. Let's try to minimize our manufacturing costs. Again, I'm just playing around here. So instead, my goal is to minimize manufacturing costs. So I still have the same kind of constraints, but I can rerun this and I will get likely a different answer. Actually, here it didn't change. So it stayed the same. Or what if I try to, let's see if I can get one to change. Let's try to maximize my net income instead. Maybe if that makes a difference. All right, well, no major change here. So you can play around though and see if your solution changes based on if you're minimizing or maximizing different things. And then by saving it, you have this ready to go. So let's say, when you're all done playing around, you want to go back to your original solver. What you can do is go back and hit that load save feature. You can select where you saved that original data. I know it doesn't make much sense to us here, but it makes sense to solver. And you can load it and we can replace what's in there with solver and it will go back to the original. So that's how you kind of save your original solver features, play around with some new stuff, and then load it back in if you need. Okay. So Solver is a really, really nice tool. It does take them getting used to, particularly with constraints. If you've never done constraints before, again, you want to think in terms of cells. So you're doing algebra, but in Excel notation, right? So we do have constraints here. This would be like a real world problem where we're trying to, write equations and we're writing inequalities and things like that. So a lot of your examples are going to have lots of constraints, and you really want to keep them all in mind. And we enter them again, typically using a cell reference on the left, and then it could be another cell reference on the right, but it could also be a number on the right. So you want to think about the constraints that are happening within the problem, and even ones that could be hidden, things like that you need to have an integer answer here, or things like, hey, we forgot to check that I have enough supply in stock to create the bikes, right? So I need to have that greater than or equal to 0 feature here. So it does take some getting used to, but once you get used to it, it's a really helpful tool to determine optimal mixes, whether you're maximizing or minimizing. And I've used this, again, not just with costs, but with time, shipping speeds, for instance, or length of wait times or things like that. So we can apply this in many different ways.